Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to my lecture. So in our last lecture we had shown how government through policy or public sector solutions in case of addressing or managing externality and public sector solution has both and has a role for both negative externalities and also controlling positive externalities. So that part we already discussed, and in that particular case we also discussed about how through taxation public sector solution or say as a remedy to tackle negative externalities, and in case of positive externalities, how through subsidy that public sector solution or as a remedy it can be managed, and efficient allocation of the resources will be given. And efficient allocation of the resources, what I mean is production. Like in case of steel productions, we discussed and had also shown that how production is optimum in both the cases, in case of private market efficiency level, and also in case of social optimum level. That how taxation actually helps, and their government interventions or through the public sector solution happens. And in case of positive production externalities, in that case through with the help of subsidy, government or public sector solution can happen or can manage, and thereby economy as a whole can achieve the optimum level of output and the price. Today we'll discuss about the price and quantity approaches to address externalities, and of course we spoke about price and quantity, but in case of market for the commodity, and the commodity like market for steel, market for garments, or market for textile, or say market for solar panel. So we actually had considered products or the goods and services, and there we tried to understand how farm or the producers and the affected one, like say individuals or the fishers communities, they are actually getting affected, and how price and quantity are getting optimally getting allocated. So in that particular context we say it, but then here we are trying to understand price and quantity approach with the help of price and quantity approaches, how to address externalities. So we will take the example of now market for pollution reductions. So now imagine that pollution as a target, and that is where price and quantity, how price and quantity will be determined, and will be with the help of price and quantity how pollution can be reduced. So we are actually shifting our focus from market for a goods and services to the market for the pollutions. So here our shift is basically market for the goods. So now we are shifting from market to the market for the pollution. So pollution is the concern, and as I say that for the policy makers, pollution is one of the major challenges that they are policy makers, especially government, they are very sensitive towards that. And as economists, this is also a bigger challenge, that how to tackle this pollution and how to reduce the pollutions. So this is like when we talk about market for pollution reductions, we are actually trying to distinguish between price and quantity in case of market for pollutions. So now farm can, like in this case steel producers or say solar panel or say garment or textile industry. So firms can reduce pollution by producing less, like we already discussed that if taxation is imposed, then or payment is involved in case of private solutions and taxation in case of public solutions, then firm will try to reduce the production, or by changing production methods, like introducing new technology or new machineries or equipments which can actually reduce the pollution level, and there producers or the firm will pay less. Like say in our previous examples, like if say in case of private solutions, if $100 is involved for producers to pay to the fishers community, or in case of public solutions, if $100 is imposed, for which firm or the producers will be paying to the government. So instead of avoiding payment or the tax, if firm or the private producers, if they introduce certain methods or buy some high or advanced level of equipments which reduces or produces very less pollutions or no pollutions, in a way that particular instead of that paying $100 to the other parties, they will actually pay in buying some other machineries, and that way, that is another one way that firm can actually control their productions. When we say that firms can reduce pollution by producing less or by adopting new technologies, so changes in the production methods may entail direct expenditure for pollution control devices or some other alternatives in the production process. This is what we are trying to mention. So now fines can also be imposed, but then fines related directly to the amount of pollution ensure that firms will undertake the pollution abatement in the least costly manner possible. So even if firm or the producers, they are introducing certain methods or advanced technology in the production process, because that cost also should not be very high, because it has to be either equals to or less than the payment that are involved for firm to pay to the other parties, those who are affected, or in form of taxation. So that amount that I introduce in the production process has to be less or the equals to the taxation amount. So this is what the approaches for the price and quantity to begin with. So now if we look at the market for pollution reduction, so let us first understand that how pollution market can be tackled, and then how in this particular case how efficient allocation or control of the pollution can happen. So now again we will take the example in this particular case where marginal private marginal cost, like marginal cost is of course is very important, and then for the pollution reductions, and here in this particular case private marginal cost and social marginal cost, it is actually the rising function. So we can actually see with the help of diagram. So here if we consider here price of the pollutions, like say cost of pollution on the vertical axis, and say here say we take point A, and then on the horizontal axis is basically say pollution reduction. As we move on the right hand side, As we move on the left hand side, it is actually pollution. So entire horizontal axis, it shows that level of pollutions and also reduction, but how to reduce the pollution. So it's basically the pollution level and also reduction levels as well. So as we move on the right hand side on this horizontal axis, we are actually reducing the pollution level. As we are moving from right to left, is basically pollution is increasing. So this private marginal cost and social marginal cost, it is a rising function, which means it is on the upward sloping curve, where private marginal cost is equals to social marginal cost, and say at that point where pollution reduction is at the full level, say at this point, and this is point B, and at point A where pollution level is the full, like level is the highest, and reduction is completely reduced at say at point A dash, at point B where we reach at the private marginal cost equals to social marginal cost. So as we are moving vertically, as we move along with the vertical curve, is basically cost is getting added as pollution increases, right, or as pollution decreases, because there will be most cost involvement in order to reduce the pollution level. So now the second curve is like the marginal social benefit of the pollution reductions, and we are considering as a, like, say, to make simpler, we are taking straight line, and it is nothing, this is our social marginal benefit curve, which is equals to marginal demand curve. So here social marginal benefit or private marginal benefit, it can also go downward sloping following the law of demand or law of diminishing features, but then here we are keeping it like very simple, thinking like it is fixed say at f star levels, small f star levels. So there are three points here. So one is point A, the other point is B. These are the two extreme points. But then here also there is point, say, E. So E is like point E is actually our optimum level. So as we discussed, I'm reiterating, as we move along with the horizontal axis, if I move from right to left, it's like pollution reduction is happening, and that is a method that either through taxations or through quantity control. But then as we move, it is basically either private sector solutions or through the public sector solutions, but then there is an effort to reduce the pollutions, right? So, and therefore cost will be high, and that is what it is getting measured along with the vertical axis. So now you see before P, the left hand side, that part is where marginal damage, what we call social marginal benefit, is higher than marginal cost. So in this case, either could be private marginal cost or social marginal cost, but then definitely marginal damage is higher and therefore cost is high. So at point E. So now after point B, where private marginal cost or social marginal cost is higher than marginal damage. So obviously when cost is getting higher and higher, means cost of pollution is going higher and higher than the marginal damage, means there is an effort to reduce the pollution. And when we reach at the a dash where pollution reduction is at the full level, so where cost is really high, like pollution is becoming very expensive to control, and that is where we are getting optimum level there, where pollution reduction is at the full level, but then at point A where pollution level, not pollution reduction, but then pollution is very high, where marginal damage is also very higher than social marginal cost or private marginal cost. But then certainly at point E there is no cost involved because we are not taking any effort to reduce the pollution. So but then at point E, it's like one can call, it's like socially optimal point where pollution is getting optimum, because after beyond that point, if I move right hand side, it is marginal cost is becoming higher than the marginal damage, and then below point E is like marginal benefit of the damage is higher than marginal cost. So at point E, pollution is getting is becoming optimum, and also reduction, pollution reduction is also getting like say optimum at say R star. So like AR star is the optimum level of pollution reduction level, and AP star is the optimum level of pollution levels. So this is what we can understand, that like how market equilibrium or market efficiently allocate the price and then pollutions. So what level of pollution that we can actually we can take it. And here we can take the example of even for private vehicles, for instance, pollution is required, like otherwise there is a penalty, there is a fine, and the validity for for private vehicle it is for 6 months, and it varies from car to car. So it means is basically it's a check on the pollution, like then the moment we cross that, fine will be high, because cost to the pollution, cost of pollution to the to the society or the economy or on the environment is much higher, and therefore cost becomes really high, and therefore fine becomes very high. So say at point E, so that is what I'm just highlighting again and again. So at point E is like beyond that, cost of pollution becomes really high, and therefore fine will be very high. So this is these are the examples that one can actually imagine in case of externality. But then here we haven't considered product. It's not like production of the car. We are talking about production of the pollutions, which is the byproduct, right? And there should we focus on the product, or should we focus on the pollution itself? Should we treat pollution as a commodity and then we should think about the market for that, or should we actually think about the say product itself, like for the vehicle in this particular case, or the steel in our particular case, and then we have to penalize, or we have to kind of frame a policy through taxation or the other checks. So whether we should think about that, or we should think about the pollution. So in this particular model, we are actually in the basic model, we are trying to understand, like let us imagine about the concerns and treat concern as a product, and then we see what is the quantity of that particular concern, and here concern is the pollution, and then price of or the cost of the concern is like pollution. So this is what in this particular lecture, that this is the aim that we are trying to achieve. So now let's move to efficient control of pollutions, and here we are trying to bring like taxation and the regulations. So when we are considering like price and quantity, so here you can by now you already clear that taxation is basically nothing, it is like price, and regulation is nothing, it is like quantity check, right? So just to summarize what we discussed in our previous slide, like let's just say here, like on the vertical axis is the price of the pollutions, say price of the pollutions, and here quantity of pollutions on the horizontal axis, and the supply curve, which is private marginal cost or say social marginal cost, which is upward sloping, because as pollution, we produce more and more pollution, and then cost will go up, and then say this is marginal damage or say private marginal benefit or social marginal benefit. These are equals to each other, and then say at P star we are getting or here P star say the tax or say cost of the pollutions, and here the equilibrium say at point E and say at Q star. So here 2 points across vertical axis. P star is the taxation, is the like government regulations through taxation, through price. So we impose like penalty to the bike riders or say car drivers if they don't obey or they don't check their pollutions for their vehicle. So on the vertical axis it is actually taxation, and taxation is nothing, from the model we know, is the price of the pollutions. On the horizontal axis it is the regulation, like beyond E or beyond Q star one cannot, and then higher penalty. Why? Because cost of the pollution is becoming much higher than the marginal damage or the benefit, and this is what the regulation that we are talking about in terms of quantity, right? So in this particular at point E, so this is just to summarize, like efficient control of pollutions, how it happens is like through taxation or through say quantity, say through regulations, and here pollution is a major concern, and then we are trying to understand how efficiently we can allocate. So I stop here, and then I hope this lecture helped you, and I request you to follow these two references, like selected chapters from Jonathan Gruber, and from Joseph Stiglitz. This will help you to understand much more in details with the help of various examples that are used in these two books. So I see you in my next class, and thank you very much for your attention.